Well, let's get on with our formulas. All right, so we said that there's no indication in the name as to how we go about writing the compound. So if I've got something like magnesium chloride. What I do, how I go about answering questions to start with while I'm writing out my compounds, I look up the magnesium ion on my table of common ions on my formula sheet. I know because it's written first, I'm going to find it with the positively charged ions. Okay, it's a cation. It has to be because it's named first. And I'll look it up and I'll see that it has a 2+ charge. Then I look for my chloride ion on my table of ions and looking in the negatively charged ions table part, and I'll see that it has a single negative charge. Now what I need to do is make sure that I have the correct quantities for no net charge. Okay, so I balance for no net charge. I don't want any charge left over. So if I've got a magnesium with a 2+ charge and a chloride ion with a single negative charge, I need 2 of these to balance the charge. Okay, +2 minus 2 equals 0. So therefore balanced is MgCl2. Our balancing is always done with a subscript. Okay, subscript being a little number. What about if I have aluminium hydroxide? Right, same process. I'm going to look up aluminium on my formula sheet in the positively charged ions, and I'll find that it has a 3+ charge. And then I look up hydroxide, the whole word here, and I will find that it has a single negative charge. And so, with my magnificent mathematical skills, I can look at that and I can figure out that I'm going to need 3 of these to balance, and so therefore my compound will be needing 3 of these. But because this is a complex ion, it's not just one thing, I need to use a bracket to say that my 3 here is for the whole thing, the whole hydroxide. Okay. If I don't put the bracket there, the 3 would mean 3 lots of hydrogen. Okay, so AlOH3 would say that I've got 1 aluminium, 1 oxygen, and 3 hydrogens, which is wrong, okay, because I said I needed 3 of them. So this can't be right. I have to have the bracket around the complex ion. Let's look at another one. So if I have ammonium carbonate Same thing, I'm going to look up ammonium on my table of ions, right, the whole thing. And I can see that this is an unusual cation because it's a complex ion made up of non-metals. Okay, so it's unusual, but you have to learn this one, or you have to be able to use this one. And the carbonate ion. Okay, it's also a complex ion, and we find it on our formula sheets, and we can see now that this, I need to balance the other way around. The ammonium ion has a single positive charge, and the carbonate having a 2 negative charge means I need 2 ammonium ions to balance this. But my rule for the bracket will be the same. I need to indicate that I want 2 ammonium ions for every carbonate. And again, if I didn't have the bracket, then this would be quite strange. With a 40, it would be 42, wouldn't it? If I didn't have the bracket. That doesn't look right. Because it's wrong. I hope you've also noticed that when we write our formula, in this format, there's no charge written on the compound. Because we ended up with no charge overall, there's no charges on here. So I've written it out like a sum with charges on it to show you what I'm doing. But I also don't write this. Okay, I don't write the charges once I've written the compound. Let's do one last example. So lead oxide. But this time you can see, because there's multiple ions of lead, I've needed to put in the Roman numerals in my compound here. So I don't even need to look this one up on my formula sheet because I'm told straight away what the charge is on the ion. What I could do, I could look it up and I would see it's obviously a 4+. My oxide ion, 2-. What do I need to do to balance this? I'm going to need 2 oxide ions. And so I end up with PbO2. Does that make sense? Yep. All right. So it might be time for you to have a little bit of a practice using those